This is the inner side quest. I'd like to cover really quick how to set up the Oculus Link. So here, if I go click the control panel, make sure you have this USB cable connect your Quest to your PC. Then you can click Quest Link. This allows you to simulate the Rift through the Oculus Link. So now the screen is loading. We'll see. It should have something pop up in a second. All right, so this is basically the interface of the um, Oculus Link. So what I will do now is to relaunch my Unreal program. So here I will just make sure you have this program. It's called Oculus running. Then I'm going to actually quit the Quest. I don't need the streaming anymore. Then I'm going to launch the Unreal, right? So I will go to, and then I will run this. Because I have the Oculus Link right now activate, so the PC computer is now connected with the Quest, is treating Quest as a Rift. So you can see it's definitely trying to load all the content from the pre-existing library. But also when you play the VR game, now if you go to the drop-down menu, you do have these options called VR preview. So this is basically use your computer PC to power the game. It's not really a mobile VR, it's more like a PC VR. Okay, but here if I play, so you are able to basically see the screen uh, directly from here. So you can see the bloom effects, you can see the dynamic shadows from this controller. You see everything just as expected. Okay, so this is basically is using you can use Escape to get out. So this is using the Oculus Link to simulate this VR. However, I like to mention is if you play here, the rendering effect is not necessarily the same as a mobile VR. That's the reason you have to eventually package. Is go to platforms, you go to Android, and you're gonna package your project, and then create the installation file. Once you have the installation file, you can install this app into the VR headset. Then you can do the test. That is a true, actually mobile VR. All right, so let me just run this app. I already installed this. Later I will do a tutorial how to do the packaging, how to install. But I want to just let you take a look at the final result, which is different from the one you see on the screen. On the screen you have these bloom effects. You have this relatively accurate, high resolution material. But now, if I really just ignore the Unreal, just run this directly through the Quest, you will see the result is different. So let me do this through the side quest, which is the way you can cast. I can cast the screen directly into this computer, so you can actually see what I see on my Quest. Okay, and also I'm going to exit the Oculus Link because I'm not really doing any Oculus Link anymore, right? So exit. So through this interface, you will basically see the default. Yeah, this is the default Unreal. Sorry, the default Oculus interface. Okay, so I will go ahead, just do a really simple. You can see my hand is right here. So I will just run this installed app, which is already done a few minutes ago. So unknown resource, you can see this is basically the VR5. This is what I just installed not long ago. So if I run this VR5, just take a look at the screen, you will understand the quality is quite different. So first thing you might notice is its bloom effects is totally gone. You do not really see the bloom. If I use this teleporter to go closer, you see this bloom is totally not there at all. The reason is when you're running this mobile VR, the bloom is actually not gonna be very easy to achieve. It's more like a post effects. So I would recommend do not do the bloom. Actually, just do the regular lighting. If you really want to do bloom, you can actually do a fake bloom in the future. So here, I can go ahead and navigate the other side. You do see the IES lighting is actually available because I treat this as a static light, and I use the IES for the light profile. Once you bake the shadows, the light map is actually recognized right there, so it's pretty cool. And also you see these reflections from the sphere. The sphere has a shadow as well, so that's really nice. If I do navigating, sorry, I have to kind of switch my controllers. Um, so once I got into the shadow, you do see this controller became a little bit darker. That's really nice because the shadow from the wall is actually block the sunlight to these controllers. So this controller is fully capable to receive a shadow. The way I did is I make this wall as a movable object so you can cast dynamic shadows. Dynamic shadow means the shadow can interact with the dynamic objects. Right. So here I can see, but if I really navigating to another side of the space, and here you see this controller do not have any shadows. The reason is this wall is not a movable wall. It's a static wall. So the shadow you cast it here is actually static shadow. The static shadow does not interact with dynamic objects. So this is kind of different. But the other wall here, this wall is a movable wall or the movable objects. So the shadow is dynamic shadow. That make this wall be able to cast. So if I just to prove the concept, navigate inside. If I get closer to the wall, you'll see this controller became dark. Okay. All right. I think that's it about this difference between these two. So you can get a sense of the mobile VR and the PC VR. What's the difference between? This is a tutorial. I like to talk about various project settings related to VR, especially how to set up the different render mode, anti-aliasing, and all the cool features. Before I start, I just want to point out there's actually already quite a few good tutorials provided by Unreal. It's talk about what is the best practice to create the good practice for VR. So later I will basically post this online, so you will be able to follow this. I will just go through this really quick. Basically, if you are a beginner for the virtual reality, the best way to practice is just follow these tutorials, this link provided by Epic. I think this is based on older version Unreal Engine 4, but the knowledge is pretty consistent, the same. In general, it encourages you to set up the render as forward render with settings anti-aliasing as MSAA, and also it's recommended to enable instant stereo. Is recommended to turn on the mobile multi-view. So all of these settings you can easily find from the project settings. So here in my Unreal, if I go to project settings, which you can find here, settings, project settings, then you can go to a group. This is called render under the engine, under the rendering. Then you can see all the features. So for example, here I already set up this anti-aliasing as MSAA. So that's exactly match the recommendation. If you really drag forward, you can see there's many features you can turn on, turn off. The key point is in the section called forward render, I do check the forward shading. So this is the option I do have. And then I have in the VR session, I do have this instance stereo turned on. I have the multi-view turned on. I did not turn on the HDR. That's the reason the blooming effects in mobile VR is actually not being rendered. The reason is if you really turn on the HDR, the post processing will be quite expensive. It's definitely not a good practice to run this in a kind of Android mobile VR platform. Okay, so Oculus Quest is pretty much as a smartphone. It's not really capable to do this really high-end post effects, also the ray trace and lumen and reflectivity in real time. So this is something I just want to point out. All right, even here I check the bloom; it won't really kick in the blooming effects because there's no HDR. All right, so this is all the options I set it here. I do want to mention is these settings is also available if you actually go to the File Explorer, right? And if you go to the just go to this project settings, this is under the config folder, and here you can see the default engine. If you double click, you can basically see the text script. So that's exactly the same as what we just identified here in the within Unreal. So here the mobile HDR is false, the multi-view is true, instance stereo is true. Right? So this is the text editor. You can also edit directly here, default engine INI file. There's other INI file like input. In the future, we'll talk more when we get into the motion controller input, but it's all accessible right here. Okay, under the config folder. So back to Unreal, the project settings, we followed exactly the same as is suggested. So this is I preferred way, so you don't have to struggle. There's other settings. If you follow this, there's a variety of the variables you can play with. Basically, if you use my template, you don't have to change anything. It's already being set as it should be. Okay. So that is about the project settings. I do want to just show you a few examples. If you do want to play around, what happened if I turn on HDR? What happened if I turn off multi-view? What if I'm not using forward render? I'm just using the default render. So what is the difference? To save time, I'm not just gonna compile and repackage for each one. Here's a quick table. I showed a few result. I tested different combination of these variables, forward rendering, instance stereo, multi-view, mobile HDR, and then this is the result, right? So basically, this is the kind of result based on my machine and the Quest 2. If I do not turn on the multi-view, basically I lost one left eye view. So that's the seems like the direct relation between the multi-view to this rendering result. So the green one means everything looks fine. So if I do not do the forward rendering, but I turn on the multi-view, everything looks fine, but no IES lighting. So the lighting looks just like a standard point light. There's no IES profile. So I think this IES has something to do with the forward rendering. And here I can show you the video. This is a video I captured on the various combination of these rendering settings. So this is the package produced without using forward rendering, right? Just a default render. So here you can see once I log in, everything looks fine, but this IES light profile is not being loaded correctly, right? So that's one of the reasons you do want to turn on the forward shading. Otherwise, this IES is not correct. So the second render, I turned it on, the forward render. And now if I look around, right, you can see this light pattern looks correct. So IES is rendered in the right way. However, there is some issues in this version. You can tell the dynamic objects, the sphere, does not cast a shadow. The reason is the reason it doesn't have a shadow is I forgot in a direct sunlight. If you look at here, is your sunlight, right? You have to turn on. There is a setting called. If I go to details, go all the way down, it casting the dynamic shadow. So I think this is a feature. It's called cascaded shadow maps. You have to turn on this distance. So by default, I think it somehow is 0. Bouncing up to 2,000 or maybe 20,000 if you want to make it even more, consistent, right? So you can see the shadow will be computed within this distance. I think 2000 should be fine. And then I change the number of dynamic shadow into 1. So it's only calculated 1 shadow out of this, 1 pass. So that means all the dynamic objects, including the sphere, including our motion controllers, including this gun, will receive the shadow from this direct sunlight. This is called the dynamic shadow. Again, this is posted directly into this document. I will again link this document to you so you will be able to see the result. So this is the article talk about use cascaded shadows to calculate the shadow for dynamic objects. All right, so back to Unreal, and also I did another thing I'd like to mention is for the wall, right? This wall, is the wall I selected? Yes. So for this wall, if you check the this mobility features, I changed this from the static to the movable. The reason is if you have a movable object, the shadow will be a dynamic shadow. So if I move my motion controller within the shadow, the motion controller will receive some shadow from this wall. But on the opposite, for this wall, this is a static, right? So the shadow casted from these static objects is called static shadow. It's efficient for light map, but if I move inside, right, this shadowed area, you won't really see the shadow received from this wall because this wall is a static. Okay, so this is sometimes you do want to make some objects as a movable if you want the shadow be able to cast into any dynamic objects. So this is the trick. And here, to save time, I will just play the video I captured for that setting. Right? So here I'm inside the game. I'm actually inside the sphere. So I'm trying to just, push the sphere away. So now if I see that the sphere has a shadow, right? Because the shadow is casted from the sun, for sure. And also, better than that is you can see the shadow from the motion controller on the ground, a little bit tiny one. And I can also approve if I get inside this shadow area, right? You'll see this controller became pretty dark. And then move out, it became bright. Because this shadow casted from the wall is dynamic shadow. If you don't really care about this shadow change, you can change all the objects to static. It's totally fine. It's actually maybe more efficient because you bake the light, right? The shadow will be a part of the light map. So that will be similar like this wall. No matter how close, right, you get into the shadow, get into the the wall, the motion controller always bright because there's no shadow casted on top of these dynamic objects. But if I go here, it will become a little bit darker, right? The reason is this shadow is dynamic. Dynamic shadow will interact with the dynamic objects. I hope that makes sense. There's a different kind of relationship there. But bottom line is you do not see the bloom effects. You see the IES lighting. So that's exactly as what we expected. So when you package your project, just keep in mind you have those options. So for me, I will just show you really quick how to do the packaging. Once you have everything assembled in your map, you just need to go to mode settings. You make sure you switch the game mode to VR game mode, and then you are able to platform, Android, and then you can package the project. If you don't have this option, it's called Android option. That means probably you didn't install the full, I would say, the Android package when you do your Unreal installation. In this case, you probably have to go back to your Unreal Epic game launcher, and then you have to add that Android features on top of your Unreal. So here, this is my current 5.0. If I check the options, right, I do see I have a few components being added. So Android is being added. For some reason, if you don't have it, you have to check, and then you have to reinstall this package. It shouldn't take too long. In the future, if you want to add more platforms, once you build HoloLens, for example, or iOS, you come here, you're adding this package in. Okay, so this is just some additional features available when you install the Unreal. Okay, once you do that, then restart Unreal, you should be able to have this Android option right here. Okay, I have some other tutorials. Old one talk about how to install the Android Studio, which is also required as a way to package for Unreal. I think I will just link that old tutorial. You can find Android Studio installation. Plus, for the virtual Visual Studio, you also have to, make sure you have the latest Visual Studio SDK installed. So again, this is covered in another old tutorial. As you can see here, I have Visual Studio 2019. If I go to modify, I do have SDK already installed for my Windows 10. Right? If you don't have it, you have to check, and then it will install the correct, the C++ and other SDK package to your Windows. All right. So if you have everything installed, the way to build the package is really simple. Before you build, make sure you rebuild your lighting. I already did. I did a high. I did not rebuild my light. So everything is baked correctly. Then you do Android package or project. And here you can just give a new name to a folder. I would recommend you do this in a folder outside your current project, because this could be something in the future you're gonna delete or copy over. So don't be confused with other files. I put this into a folder just for build. So now it's packaging the project. If I show the output log, you'll see it's trying to compile everything into an APK package. Once you have this package done, then you are able to install the Quest. Okay. So let's wait. This depends on how complicated. If it's the first time you run the installation, the packaging, this will take for a while because you're trying to bake or cook all the component, material, shader, lighting, all together. But if you run this multiple times, Unreal will actually remember the cache from the previous build. So it will be faster the next time when you build. Okay. But also it has some side effects. Is if there's some error message in earlier build, when you build again, it might not be a clean build from scratch. Okay, here is the package complete. Yeah. So I can take a look at this first. So that is in TM. Oh, by the way, no. So if you do want to have a clean build from beginning, you could wipe out the folder called binaries build derived data cache, intermediate, and saved. You can delete this folder. So the file here is actually cached file. Then you start with a fresh build. That could be the most clean way to build. But anyway, I don't really worry about this because I think my build is fine. I don't have some previous error message. So if I go to my build folder, build, too many folders, and then you can see this is the ASTC and this is the installation file. Okay, so I'm now ready to run the installation. To run the installation is really simple. First thing, just make sure you have your Quest with USB-C or USB-B, whatever connected to your computer, you do not really need any Oculus Link activate. Just keep as a Quest, right? And then the way you can package is by double-click the install VR5, right? So this is basically the screen you will see. It's trying to push the data from your PC into the Quest, right? So this is called installation. Once this process is done, the file is actually all standalone in your Quest. And then you can actually unplug the mobile VR headset. Then you can test the result. Okay, so this is the whole process. You do need to sometimes look into it. If the screen pop up say, do you want to allow the connection? You want to say yes, I allow. This is kind of sometimes will freeze the installation if you don't allow the access to your computer. Okay, so it's done. To just show you, I already showed earlier at the beginning, but now I'm gonna show you one more time. So once your installation is done, you want to see the program inside. Okay, so in order to see the content within the headset, I have to using a program called SideQuest. I'm just simply cast, simply stream. So you're gonna see my screen. So now I just recording my current Quest 2 screen on the PC. Right, so as you can see, once you have everything installed, go to the app library, and here on the top right corner, you can see this drop-down menu. There's one option called unknown source. Then you'll see this is one we just installed, VR5. So click, you should be able to see the program we just installed into the standalone. So the Quest has these controllers, and also you see the bloom is not there, but everything else is precisely there. You see this is the static mesh we bring from other program, and this is the the sphere, and also if I turn around using this, I can see this IES lighting is right there. Yeah, everything is as expected, and you'll see the shadow right over the spheres right there. So if I get closer, this is my controller. So if I get closer into the shadow, you'll see the controller became pretty dark because it's within this dynamic shadow. So that's really cool. But if I navigate out into this area, even when I put my controller right behind the shadow, this desk, there's no shades on this, right? If I go into this space, the controller looks pretty bright because the shadow here is a static shadow. All right, I think that's solved all the issues we have, and let's exit. So click this home button, then you can do the quit to quit the program.